In part 4 of Bones and Bone Structure, we're going to take a look at the two types of ossification, which is bone formation. And then we'll take a look at how bone is supplied with blood, lymph, and nerves. So let's take a look at bone formation. The term that we use is known as ossification. Another term that you may hear is called osteogenesis, but simply both terms mean that we're forming bone. Now, bone needs to become hard, right? We talked about matrix in our previous lesson. That process of making bone hard and depositing the calcium salts, you're going to call calcification, right? That's a process that takes place during ossification. So we're going to take a look at two forms of ossification. The first one is known as endochondral. Whenever you see a chondro, think cartilage. Very simply, as an overview, we're going to make bone from an existing Highland cartilage model, right? So we're going to have a piece of cartilage, let's say in the arm or the thigh, that type of thing. And that piece of cartilage is going to be replaced by bone, right? Endochondral. The second one we're going to take a look at is known as intramembranous. Now, this is going to be bone that forms from mesenchyme or mesenchymal tissue. If you remember from the tissues chapter, mesenchyme is embryonic connective tissue, or it can come from fibrous connective tissue. We usually see this occurring in the deeper layer of the skin, and it produces some of the flat bones like the skull bones, the sternum, the mandible, and we'll take a look at that. So that's the second one. Typically, bone formation begins 6 weeks after fertilization, and then it continues right through adolescence until we stop growing. Some human bones continue to go through ossification until age 25. I didn't put it here, but even 25 to 30. Right? So some of our bones do form quite late in life. So let's take a look at endochondral ossification first. This is how most bones in the skeleton form. We're going to see there's something called a primary ossification center that develops in the middle of the shaft, of the diaphysis of the hyaline cartilage, and then that's going to eventually be replaced by bone, as we said before. And we can break this process into 7 steps. So this is an overview slide. This is from the Martini book. You can see the 7 steps here, and we'll go through each one of those steps. But the first 4 steps, this is kind of the initial process of ossification in the developing bone. Then the last 3 steps, right, 5, 6, and 7, this is what's going to allow the bone to increase in length, right, during fetal life and during our formative years. But we'll go through each one of these steps. So let's take a look at the first step of endochondral ossification. What you see here is a piece of cartilage. So let's just say we're making the arm bone, the humerus, and this would be where your arm bone would be. What this is a piece of hyaline cartilage. Now, the hyaline cartilage has chondrocytes. Those are the cells of cartilage. They live here in the middle, and they get bigger and bigger. They grow, they increase in size until there's just a little bit of cartilage between the cartilage cells. Eventually, since the cartilage doesn't have a blood supply, these cartilage cells die, leaving these large cavities. So basically what's happening in the first step of this endochondral ossification is we have enlargement of the chondrocytes, which are the cartilage cells. They get bigger and bigger until they form these they actually die and form these large cavities with little small struts of cartilage between these cavities, and those struts will eventually turn to bone. They'll actually calcify. The second step. All right, so this is an important step. If you notice, blood vessels grow up against the diaphysis, which is the shaft of the bone. The blood vessels stimulate osteoblasts in the perichondrium. Now, the perichondrium is just the membrane that surrounds the cartilage. The blood vessels stimulate the cells of the perichondrium to convert to osteoblasts. So what we form here now is along the edge of the bone is a thin layer of bone, because this is where the osteoblasts are forming bone, and this thin layer of bone would actually go around the shaft of the bone, and we call this thin layer of bone the bone collar. Okay, so in this step, the blood vessels grow up against the diaphysis, which is the shaft. That stimulates the cells of the perichondrium to convert to osteoblasts, forming a bone collar. Now, in step 3, notice the blood vessel isn't just up against the diaphysis at this point, it's actually penetrated into the middle of the diaphysis. So what happens here is fibroblasts, which are cells of connective tissue, they actually migrate in with the blood vessel. So as this blood vessel is coming in, it pulls along fibroblasts, again, which are connective tissue cells. Those fibroblasts convert into osteoblasts. Again, whenever you hear osteoblasts, think bone formation. And take a look in here. If you look in the middle of the shaft, what do we have? We have some new bone being formed in the middle of the shaft. This is known as the primary ossification center. All right, so you can see nice spongy bone being formed in there, and again, as the baby is growing, right, this will continue to increase in size. It'll kind of go in length this way, right, as this shaft gets a little bit bigger. Okay, so the main steps that are happening here: the blood vessel penetrates the diaphysis. It brings along with it fibroblasts. The fibroblasts convert to osteoblasts. We know that osteoblasts always produce bone, and we form our primary ossification center. Primary ossification center. Now, again, as the fetus is growing, the bone is going to remodel inside the diaphysis. And if you notice, we've developed now a cavity in here, and if you recall from our previous lesson, this cavity is known as the medullary cavity. You'll also see that the cortex here, the side of the bone, the shaft of the bone over here is becoming thicker. Before it was a thin bone collar, so you can see that this whole area is becoming a little bit thicker and stronger. All right, so in this step, basically what we have is remodeling. We form the medullary cavity. You can see the blood vessels kind of extend up now. They're actually going up towards the epiphyses up over here, and we're getting a thickening of the dense bone over here along the shaft, making the shaft a bit stronger. In the 5th step, we see kind of what happened in previous steps in the epiphyses. So if you recall, the epiphyses are the expanded ends of the bones. There's one going to be proximal, and then there's one that's distal. Here's the distal epiphyses. Same thing, the blood vessels penetrate into the middle of the epiphyses. Again, when the blood vessels penetrate, it brings in fibroblasts. The fibroblasts turn into osteoblasts, and we end up producing bone over here. This is known as the secondary ossification center. Now, it's not only happening up here, you can see another secondary ossification center forming over here. All right, so we have some nice spongy bone being formed here in the epiphyses distally, and same thing, spongy bone being formed in the epiphyses proximally. Now, As the fetus continues to grow and through our formative years, this is where a lot of the activity is taking place. If you notice, we have the secondary ossification center here where there's spongy bone. Notice though, the cartilage here stays as cartilage. This does not turn to bone ever. This is the cartilage that we find at the ends of bone. But if you were to go take a chicken bone, so you had a chicken leg, fried chicken or something like that, and you looked at the end of the chicken bone, you would see a shiny, silvery cartilage at the end. That's this cartilage. This is what's going to be articular cartilage. As I mentioned, this is the cartilage that stays on the ends of our bones. The other place that we have cartilage is right over here. So this is known as the epiphyseal cartilage. This is where bone growth is going to take place as we grow, right? The epiphyseal cartilage is in the metaphysis, right? That was the area between the epiphyses and the diaphysis over here. So this is where we find the epiphyseal cartilage, and this is going to allow for what we call interstitial growth. Interstitial growth is when our bones grow in length. And I have a slide on that in a couple slides going forward. So what they did here, this is actually a good picture. They take the epiphyseal cartilage and a piece of the diaphysis over here, and they blow it up so that we can see the as chondrocytes continue to divide and form, this epiphyseal cartilage is going to get wider, making the bone grow in length. The cartilage cells at the bottom of the epiphyseal cartilage, they start to break down. As they break down, they form these cavities right here, and now bone cells, the osteoblasts, you can see them right here, all these osteoblasts, they grow or move into those cavities and they produce bone. So as we're producing bone here at the bottom of the epiphyseal cartilage, at the same time we're making new cartilage over here, and this continues to stay growing wider so that the bone will grow in length. Right, so during our formative years, this is where all the activity is. So again, the important things on this step number 6 is the secondary ossification center and the diaphyses have the epiphyseal cartilage in between, and this is where we're going to grow our bones in length, and that is known as interstitial growth, right? Interstitial growth. The final step. So what we had just mentioned in step 6 happens all through the fetal life as the bones get longer and our growing years. And you can see here at puberty the rate of epiphyseal cartilage production slows. So what we're saying, at puberty we produce less new cartilage here, but the rate that the osteoblasts produce bone stays the same or gets faster. So eventually this cartilage is going to disappear. Once we stop growing, that cartilage disappears. We have what we call epiphyseal closure, and you see here there's like a line. This is where the epiphyseal plate or the epiphyseal cartilage was. Right? We sometimes can see that on an x-ray. So that tells us that this bone is done growing. It's not going to grow in length any further. Also, I just want to point out, so the epiphyseal cartilage is gone. Notice what cartilage stays. This is the cartilage that stays at the ends of the bones. This does not turn to bone. This is the articular cartilage. Just jumping ahead a little bit from when you get into a pathology class, this is the cartilage that will wear away when somebody has osteoarthritis, right? We call that wear and tear arthritis. All right, so that we're going to call articular cartilage. So we did this already in the steps, but just to kind of formalize it, interstitial growth, right? What I want you to know is this is the bone growth in length, right? This is what makes us get taller. This is what makes our arms grow longer. The activity, like we said before, is occurring at the epiphyseal cartilage, right, also called the epiphyseal plate. And as I mentioned earlier, on the shaft side, right, where the diaphysis is, the osteoblasts invade the cartilage and convert it to bone. At the same rate, on the top of the epiphyseal cartilage, new cartilage is produced on the epiphyseal side so that the bone continues to grow in length. And then finally, once we stop growing, once we get through puberty, the process is known as epiphyseal closure. At that point, the epiphyseal cartilage will get more narrow and narrow and turn into an epiphyseal line. And like I mentioned, we can see this line on X-ray. So let's take a look at an X-ray real quick. This is obviously, hopefully you'd be able to recognize as the hand. This is the radius. This is the ulna. We see some of the carpal bones forming. Right, we should have 8 of them in there, but they haven't formed yet. Right, here's our thumb, the second finger, right, the pointer, the third finger, the middle finger, the ring finger, and then the fifth finger would be the pinky, just to give you some of a bearing. These bones are called metacarpals. So if you take a look here, and then these bones are called, these bones are called phalanges over here. Let's go to this one. It's nice and easy to see. So if you notice, this phalange looks like it's 2 bones. In actuality, it's 1 bone. This kind of dark line right here, that's cartilage. Cartilage shows up as a darker shadow on X-ray. Bone shows up as a whiter shadow. So this is the actual growth plate. This is called the epiphyseal cartilage. Eventually, once this child stops growing, this all becomes 1 bone. Right, so all of these dark lines, here's a good one too, they marked it, this dark line right here, right there, that's the epiphyseal cartilage. Once the child stops growing, we now have complete ossification. So just to give you some bearings, again, here's the radius, here's the ulna. Now we have our 8 carpal bones over here, and then we have our metacarpals. If you notice, we'll go back for a minute, let's go to the 4th phalange right here, 4th proximal phalange. Let's find it on this person here, 2, 3, 4. This is where the growth plate was, right here. Right? We don't see it anymore. Here's the growth plate gone. Right? It's a little bit of a line. Here's the growth plate where it was in the child. This is now the epiphyseal line in the adult. And you can see here was the epiphyseal cartilage in the child. I didn't point this out before, but since we're looking at the line now, this is where the epiphyseal cartilage is. Let's go back to the adult. And that's where the growth plate once was, and now it's a line. All right, so sometimes you see them really well, sometimes you don't see them that great, but those indicate that those bones are not growing anymore. Okay, so interstitial growth, as I mentioned, is growth in length. The other type of growth that's occurring at the same time, not only do our bones grow in length, they need to grow in width, right? Otherwise they would be like a toothpick. So we call this oppositional growth. Right? So here what I'd like you to know is oppositional growth is where the bone grows in width. So what's happening here is the compact bone is going to thicken and strengthen by adding more and more layers of the circumferential lamellae. And we did this in a previous lesson. I put this slide back here again just so you could see it. This is a piece of the compact bone. These are the circumferential lamellae. This ring, right? This ring, all of this. By adding these, the bone is going to get thicker. Okay, so that's what we're saying there. The compact bone thickens by adding layers of circumferential lamellae. All right, the cells on the inner layer of the periosteum, they differentiate into osteoblasts, and we know that osteoblasts always produce new bone. Okay, so I'm saying it again, I'm just kind of repeating it here. Oppositional growth adds a series of circumferential lamellae. Eventually, as we add these rings here of circumferential lamellae, these are going to differentiate and become osteons. They're actually going to form an osteon here, an osteon here, right, an osteon here, and then we'll add more layers of circumferential lamellae out over here, and the bone continues to get thicker and thicker. At the same time that oppositional growth is occurring, that the bone is getting thicker, that medullary canal needs to widen also. And that's my last statement here. Osteoclasts inside the medullary cavity are going to remove the matrix, making the medullary cavity widen at the same time that the bone is getting wide. Right? Otherwise, we would have just a thin medullary cavity in between and too thick of a compact bone. So as the bone gets wider this way, this cavity over here is also getting wider. Right? We'll kind of disintegrate some of this bone here to make this cavity wider. Right? So with that, it is proportional. Okay, so that's oppositional growth. And again, just to go back, interstitial growth is bone growth in length. Okay, so that's it for the endochondral ossification. Let's take a look at intramembranous ossification. If you recall from my first slide, this is the second type of bone formation. Some people call it dermal ossification. This is because it occurs in the dermis of the skin. If you remember that the dermis is the part under the epidermis, and it produces bones that are going to be our cranial bones, the mandible or the jawbone, our clavicles. More of the flat types of bones. This is broken down into 5 main steps. So if you notice here, we have a picture of a little fetus, right? We're looking kind of at the cranial region, and we're going to take a look at, in this case, the formation of the frontal bone. So the first step here, the mesenchymal cells. Again, whenever you hear mesenchymal cells, think embryonic stem cells, right? They're the types of stem cells that form connective tissue in the embryo. These are actually going to cluster together and they're going to form osteoblasts. So all of these purple cells are the mesenchymal cells. They clump together and they differentiate into these kind of, I guess, pinkish cells here with the blue nuclei. These are the osteoblasts. Now, if you look closely, I'm not sure if you can see it on this picture very well. I'm trying to go to an area where we can see it. These are all osteoblasts here. See that thin little blue line above the osteoblasts? That's the matrix that hasn't calcified yet. And if you remember from a previous lesson, we call that the osteoid. That's the uncalcified matrix. Once it calcifies, we get a little bit of bone formation here. All right, so really that's all that's happening in this step, is that the mesenchymal cells are kind of clustering together and they turn into osteoblasts. The osteoblast lays down some of the osteoid, and that osteoid starts to form bone, and we get these little bony islands. Right, here's a bony island here, a little bony island over here and here, that type of thing. In step 2, the process continues, where you can see the bony islands are getting bigger and bigger. This picture is a little better. You could actually see the osteoblast real well, and you can see the blue line right here. That's the osteoid. So it's making these bony islands better. But you'll notice these bony islands form these little points that stick out, like right here. This little point right here. Here's another good one over here. These little points are known as spicules. They are what are going to form the struts of spongy bone, which we had learned in a previous lesson are called trabeculae. If you notice, the spicules are starting to extend out and they're starting to approach these blood vessels. They're eventually going to actually surround these blood vessels, which are going to form our bone marrow. They're in the pockets or the spaces between the trabeculae, and we'll look at that in a minute. So in this step, we just see that the bony islands are getting larger and larger, and they form these spicules, little points that are starting to go around the some of the blood vessels. Eventually, you'll see that the spicules have gone around and actually enclosed the blood vessels. So here we could see a blood vessel that's trapped in the bone. Right, here's another one, here's another one. So all of this now is spongy bone, and these little connecting points here, this is going to be what's going to be the trabeculae. So the bone growth just continues to occur and trap these blood vessels. Again, in these spaces here, this is where the bone marrow is going to be. So this process just continues. And you can see again as the fetus is getting older and older, that it becomes more and more organized. Now we're actually starting to see the osteoblasts forming a straight line up here. This is where a thin layer of compact bone is going to form. And then if you remember, the other end of flat bone also has a thin layer of compact bone that's going to form over here. All right, so the process just continues. We have continued deposition of bone by osteoblasts located close to the blood vessels, right? We really want to make sure that these blood vessels are being trapped inside the bone because that's where the bone marrow is going to be. Eventually, we'll have a thin layer again of compact bone here, a thin layer of compact bone here, and then the spongy bone in between. These are going to be the trabeculae. Here's where the bone marrow is going to be. Remember we said it was like a sandwich almost, right? We had a layer of bread here. That was from a previous lesson. A layer of bread here, and then nice spongy bone in between. And you can see this is what it would actually look like, right? We could see thin layer of compact bone, thin layer of compact bone, and then nice spongy bone in between. Again, all these little struts of bone are called the trabeculae, and then the spaces here is where the bone marrow goes. And again, we called from a previous lesson, we called the spongy bone the diplo. So that's the intramembranous ossification. Again, think of the flat bones, skull bones, the mandible. They're going to form in this method. Okay, so that's the end of bone formation. Let's finish up this lesson by taking a look at the blood supply and a little bit about lymph and nerve supply. So if you haven't noticed, I think I've mentioned it before, our bones are extremely vascular, right? They have a lot of blood vessels. So the main blood vessel that enters a bone, you're going to call the nutrient artery, right? There'll be a vein that accompanies it. Most bones have one nutrient artery. It goes through a little hole in the bone. Remember that a foramen is a hole. We call that hole the nutrient foramina, or the nutrient foramen. A big bone such as the femur is going to have more than one nutrient foramen just because it's so large. So here's a picture from the Martini book. If you look in the shaft right over here, right about there, there's a hole in the compact bone, and then the artery going in is the nutrient foramen, the vein going out obviously is a nutrient vein. Then you can see the blood vessel goes in and it just expands throughout the diaphysis, spreading throughout the bone. At the metaphyses, where the growth plate is, where the epiphyseal cartilage is, the blood vessels that go in are called the metaphyseal blood vessels. So again, there's two growth plates. There's going to be one proximally. Right? So these blood vessels right here are the metaphyseal blood vessels. And then down over here, same type of thing. This is where the growth plate is. That's the metaphyseal blood vessels. We want to make sure that that growth plate has adequate blood supply for bone growth. The last blood vessels I'd like you to know are called the periosteal blood vessels. These are going to be running in the periosteum, and they're supplying the superficial osteons, so the osteons that are on the periphery of the bone, and then also they're bringing blood to the secondary ossification centers, which we just saw are important for interstitial bone growth. So you can see out here is the periosteum, and this is the periosteal blood vessels running straight up and down this way. Okay, so the blood vessels we want to know are the nutrient artery and vein, the metaphyseal artery and vein, and the periosteal artery and vein. This is the picture from the Tortora textbook. Same type of thing, right? You can see the nutrient artery here. Here's a good nutrient foramen. They do a good picture with that one. And then here's going to be your metaphysis. So this is the metaphyseal arteries. Okay, and here's your periosteal arteries and veins out over here. Finally, the periosteum also contains lymph vessels and a network of sensory nerves. And so when we actually injure the periosteum, say from a broken bone, this is where we're actually getting the bone pain from. It's the periosteum that has a good nerve supply.